Every gasoline engine is designed to run smoothly, but under certain conditions, a sharp metallic knocking sound may appear. Drivers often call it piston slap or say that the engine is knocking, but in reality, this phenomenon is known as detonation. Unlike normal combustion, detonation creates an uncontrolled explosion inside the cylinder, which can severely damage the engine if left unchecked. To protect against this, modern engines are equipped with a knock sensor, an electronic device that monitors detonation and helps the ECU, engine control unit, adjust ignition timing for safe and efficient operation. Detonation, or detonation combustion, occurs when part of the air-fuel mixture in the combustion chamber ignites spontaneously instead of burning progressively from the spark plug. As the flame front compresses the remaining mixture, the pressure and temperature rise to a point where it explodes violently. This rapid ignition produces shock waves traveling at speeds over 2,000 meters per second, creating a metallic pinging sound and subjecting pistons, cylinder walls, and the cylinder head to extreme stress. The main causes of detonation are fuel quality. Low-octane gasoline is less resistant to abnormal combustion. Engine design, compression ratio, combustion chamber shape, piston crown design, and spark plug location. Operating conditions, lean or rich mixture, ignition timing, carbon deposits, heavy loads, or high temperatures. Increased detonation leads to higher heat transfer, excessive wear, and potential engine failure. The likelihood of detonation depends primarily on octane rating, engine design, and load conditions. For instance, high-compression engines require premium fuel to avoid destructive knocking. The knock sensor is the engine's ear, detecting abnormal vibrations caused by detonation. Its core principle is based on the piezoelectric effect. Inside the sensor is a piezoelectric crystal that generates voltage when subjected to mechanical vibrations. The stronger the knock, the higher the signal sent to the ECU. When the voltage exceeds a threshold, the ECU immediately retards ignition timing, reducing cylinder pressure and preventing further knock. The system constantly adjusts in real time, ensuring maximum power output while maintaining fuel economy and engine safety. If detonation is minimal, the ECU allows more advanced timing to improve efficiency. If strong knocking is detected, the ECU reacts instantly to avoid engine damage. If the knock sensor fails, the ECU loses the ability to fine-tune ignition timing. In this case, the ECU sets the ignition to a safe mode with retarded timing to prevent damage. The engine will still run, but with noticeable drawbacks: reduced power output, sluggish acceleration, higher fuel consumption. On the dashboard, a check engine light will appear, signaling a malfunction. While the car remains drivable, long-term operation without a functioning sensor reduces performance and increases fuel costs. A faulty knock sensor can be identified through several symptoms: loss of engine power, poor throttle response, higher fuel consumption. Check engine warning light, occasional black smoke from the exhaust. To check the sensor, a digital multimeter is used. Measure the resistance of the sensor and compare it to factory specifications. Test the voltage output. With the sensor disconnected, tap it gently against a hard surface while measuring. A working sensor will produce a small voltage spike, 30 to 40 millivolts. The stronger the tap, the higher the voltage. If there is no response, the sensor is defective and must be replaced. The knock sensor is a small but critical component that protects the engine from one of its most dangerous enemies, detonation. Without it, the engine would be forced to run in a compromised mode, leading to poor performance and increased fuel consumption. By continuously monitoring vibrations and adjusting ignition timing, the knock sensor ensures that the engine delivers maximum efficiency, power, and durability.